So today's class is about function. Length or the relation F from A to B. The relation from A to B is said to be a function if for every pre-image X belongs to a image domain, there exists a unique image Y belongs to B such that Fx equals to 1. So what does it mean? Try to see. Suppose this is A, this is B. This we call as domain. This which you have studied in class 11. This is codomain. Okay. For every pre-image, suppose there are elements 1, 2, 3. Here is element xy. Somehow, if I am relating this, can I call it as a function? It is not a function because for pre-image 3 there is no image here. F is not a function because for pre-image 3 belongs to A, there exists no image in B. So this is a case. Every element here should be uniquely associated with the elements of B. So uniqueness, try to understand. Take another example here. Like there are two sets X and Y. So the relation is defined between X and Y. Whether that relation is a function. Suppose 1, 2, 3, 4, 5. Suppose 1 is related to 3, 1 is related to 4, 2 is related to 5. You can say every element is engaged here. Is it a function? No. Because for every pre-image there should be unique image. Uniqueness means the element should have only one image, but for this you are having two images. Just like one student studying with two teachers at a time, not possible. But you can, so the reason here is for the pre-image 1 has two images 3 and 4, that is f of 1 is also 2, sorry, f of 1 is 3, f of 1 is also 4. So in this case this is also not a function. Okay, let's take another example. This is related here, this is related here, this is related here. Can you say, is it a function? In this case, it is a function because for every pre-image we are taking unique image. Means for pre-image 1, the image is 3, for 2 the image is 3, but these two are distinct. Okay, so in this case you can call that this is a function. Just like 2 students studying with 1 teacher at a time is possible, but one student studying with 2 teachers not possible. So what is our conclusion then? Okay, this is f is a function. Okay, let's take one more example. What about this? This is element, this is one element. So what do you say? One element is left out here. So this is a function because we are talking for every pre-image there should be an image here. So conclusion is nothing should be left out here and 1 should not go to 2. This is a function, but here is a case, though it is codomain, the elements which are associated to the pre-images will be called as range. When it is a function, you will have codomain, range will be there, domain will be there. Okay, so because we are doing a revision, so we will go to the point now. Point means types of function, 2 main types you will be studying here. That is one function, one, that is injective. Injective is what? F is a function from A to B is said to be 1 if x1 x2 belongs to A. x1 x2 belongs to A. Fx1 x1 not equal to x2 implies fx1 is not equal to fx2. What does it mean? The meaning of this is, if suppose there are elements in a domain, some elements, suppose A, B, C, D, E. When I say x1, it should be a function first. Only a function can be 1, 1 or on 2. So when you say x1 is not equal to x2, means these two are distinct. They are elements in the codomain will be distinct. Means A will be related to C. Suppose B is related to B. So in this case, though any element is left out here, it is called a 1, 1 function. But if anything is left out here, then it cannot be a function. So now you can say this is a 1, 1 function. Because when you say these two are distinct, their images also distinct. Or if you say these two are same, the image will be same. Contradiction. So other way you can say in that way. Okay, onto means subjective. This I am keeping just to tell you. F is a function from A to B is said to be an onto function onto function if that is for all, that is for all, for all images. When you talk about for all images, you are talking about this one. So here it is a function, it is one. But when you talk about all images, means everything has to be related here. There exists a pre-image. For all images, there exists a pre-image. So if I take this one, we can say here F is not on true, because for E there is no pre-image here. Okay, now let's see another one. What about this? Suppose 1 is related here, 2 is related here, 5 is also related here. Sum. So what will be your opinion? This is a function first. This is also onto function because no element is left out. But this is not 1 because 2 elements are going to 4. You can say F is onto but not 1. Then we'll talk what about 1 and onto. This meaning is bijective. F is a function from A to B is said to be bijective if F is 1 and onto. So that means what you conclude? 1 will go to 1, 1 will go to 1, nothing will be left out here. So if you take one example here, so if you take an example, say 1, 2, 3, 4, 5, 6. Suppose this is related here, this is related here, this is related here. Say first it is a function because nothing is left out and one element doesn't go to 2. It is 1 because when elements are distinct, images are distinct. Onto because no element is left out. So you can say here F is 1 and onto. Okay. Now what you see again? Codomain and range both are same. So you can say codomain equals to range here. Codomain equals to range. One conclusion, because suppose anything is left out here, then codomain range will be different, but it cannot be onto. That is why codomain and range has to be same. So when it is 1 and onto, if F is a function from A to B, F inverse will be a function from B to A. But we will not be talking about this year about this because this is not in the syllabus now. Only we will talk about 1 and onto functions, questions based on this. Okay, let's see the first question. So let A is equal to 1, 2, 3. Question number 1. let a equals to 1 2 3, b equals to 4 5 6 7, 4 5 6 7. Okay, and let f is equal to, f is given as the elements ordered pair 1 4 2 5 3 6, 1 4 2 5 3 6. This is given to us. Be a function from a to b, be a function from a to b. This is given to us as a function. This came in 2011. Let's see how it is solved. State whether f is 1 1 or 1 2. State whether f is 1 1 or 1 2. Very simple. F, okay, a to b 1 2 3 4 5 6 7. What is f? 1 4 means 1 is going to 4, 2 is going to 5, 3 is going to 6. So what is your conclusion? It is 1 1 but not on 2. So conclusion is f is 1 1. Therefore, so here f is 1 1. Why 1 1? That distinct elements have distinct images. So you can write x1 not equal to x2 implies fx1 is not equal to fx2. So you can say f is not 1 1. What about on 2? Now this is not on 2 because 7 is left out here. So you can say here f is not on 2 because for the image 7 belongs to B, 7 belongs to B, there exists no element, no free image in A. Okay, so main question will discuss about modulus, signum, greatest integer functions are 1 1 on 2 or not. Let f is a function from integers to integer. Z stands for integer to integer, such that fx equals to mod of x. Mod of x is where mod x is a modulus function. Okay, verify if f is 1 1 or on 2. Okay, very simple to understand. Z set of integers, integer to integer. The function is from integers to integer. So integers what will have? 0 1 2 3 like this, minus 1 minus 2 minus 3 like this. Here also 0 1 2 3 minus 1 minus 2 minus 3 like this. Okay, now modulus of x. So first you understand what is mod of x. Let me define it. Mod of x equals to x when x is greater than equal to 0, minus x when x is less than 0. Meaning is very clear. That is when you take two mod of 2 will be, mod of x will be, when x is greater than 0, the x is 2 means greater than 0, the mod of 2 will be x means 2. Okay, so when x is minus 2, the mod of minus 2, how do you define? When the element is smaller than 0 means negative, this one you write negative of x. So that will be negative of x. What is x here? Minus 2. What is your conclusion? In either of the case, the value is positive. That means mod of 2 is equal to 2. Mod of minus 2 is also 2. Means mod of 2 is going to 2, minus 2 is also going to 2. Got my point? So clearly it is not 1 1 function. Second, write x1 not equal to x2. x1 not equal to x2. This is minus 2. x1 not equal to x2, but fx1, this is going fx1, this is going fx2. So fx1 equals to fx2. Actually what it should be, if x1 is not equal to x2, then your fx1 should not be equal to fx2, but you are getting same. Therefore f is not 1. Okay, now the conclusion is, what is the modulus making here? Any element you take, positive becomes positive, negative also becomes positive. That means all the elements in this side will be related to this part only, because minus 3 will be related to 3, minus 4 will be related to 4, minus 5 will be related to 5. So negative part is not touched here. That means for onto no elements will be left out here. But what you find, there are some negative integers for which there is no pre-image here. So you can write f is not onto, f is not onto, because for images minus 3, minus 2, minus 1 belongs to Z, that is not Z here, codomain. Codomain, there exists no element in domain. There exists no free images in domain. Okay, if this question is changed, if this question is changed, f is a function from natural number to natural number, is a function and defined as fx equals to mod x, is f a bijective function. Is f a bijective function. So look at here, natural number to natural, very easily you can understand. Suppose this is our domain and codomain. Okay, this is a natural number, this is a natural number. So natural number starts from 1, 2, 3, 4 like this. Here also 1, 2, 3, 4 like this. So what is mod of? Modulus is defined. Okay, fx is equal to mod x. That means mod of 1 is 1, mod of 2 is 2, mod of 3 is 3, like this. That means distinct elements are related to distinct elements, like this, 4 to 4, like this. Second set is very clear. It is 1 1 because x1 not equal to x2, fx1 is not equal to fx2. So you can write f is 1 1, since because x1 not equal to x2, fx1 not equal to fx2. This is clear. Okay, what about on 2? Because any element you choose here, suppose I have chosen here 100, then obviously 100 is also here in the natural number, because mod of 100 is also 100. That means if you choose any element here, you find an element here. So how to write? F is on 2, because for every image in codomain, every image in codomain, there exists a pre-image in the domain. There exists a pre-image in domain. So that you can write, for every image you can write here y in codomain, there exists a pre-image x in domain such that fx equals to 1. So it became 1 1 and on 2. Therefore it is a bijective function. F is a bijective function. Okay. Now, if the same question is asked here, this is homework for you. F is a function from real number to real number. You think of such that fx equals to mod x. I have taken real number to real number. Then you have to justify, is f 1 1 or on 2. This is the task for you. Okay. Now let's change the question. Signum function. Before that, let's discuss greatest integer function. Greatest integer function, that is your fx is box x. How do you define it? Now you define that box of x equals to x. Greatest integer means outcome will be integer, not at all decimal. Outcome will be integer. What type of integer this? Now this will be between n and n plus 1, where n is an integer. N is an integer. Okay. To understand this, see a number line like 0, 1, 2, 3, -1, -2, -3. So the outcome will be integer. That integer either equal to n or smaller than this. Means suppose I take value of 0. 0 is an integer, will remain as 0. Suppose I take -1. This is an integer, will remain as integer. But if I pick up 0.5, look at here, 0.5. So 0.5 has to be an integer. So 0.5 has to be an integer means it is between 0 and 1. So the outcome can be smaller than this but cannot be bigger than this. So meaning is it cannot be the value outcome is an integer which cannot be more than this. So obviously 0 will be smaller than this. So that is 0. Similarly, if I take 1.5, 1.9, what is 1.9? Has to be an integer. So what is integer? Now that is -1.9 is in integer. If I take that side, this will be bigger than this. So I cannot take this. I have to take 1. So this value is 1. Okay. What about -2.5? Where is -2.5? Is here. The -2.5 in an integer. If I take this one, this is bigger. So value has to be smaller. That is -3. So this discussion we will do today. If f is a function from real number to real number. F is a function from real number to real number. Defined as question is f is a function from real number to real number is defined as fx equals to box of x, where box of x is greatest integer function. Okay, verify if f is 1 1 and only. Okay, so let's see then real number to real number or so what are the elements in real number? You get integers, means all the integers you get and decimals which will get in this. Decimals is fractions you will get. Okay, so let's pick up any two. So what about 1.4? 1.4 value will be 1 because 1.4 lies between 1 and 2, so the value will be 1. What about 1.9? That is also 1 because 1.9 lies between these two. So what is your conclusion? x1 not equal to x2, but your fx1 equals to fx2. So you are getting x1 not equal to x2 implies fx1 equals to fx2, because this became same, fx1 equals to fx2. Therefore f is not 1 1. Okay, greatest integer. So your outcome is integer, means only integers are related. Integers are related. No fractions will be related, because your any element you are taking here will be related to integer. Just like -2 will be related to -2. But if I say, what about -1.5? Which element of greatest integer will be -1.5? That means for -1.5 there is no element here. Got the point? So you are getting for decimals like -1.5, -1.3, etc. belongs to where? Codomain like y equals to, you can write y equals to -1.5, -1.3, etc. belongs to codomain. There exists no element x in domain for which fx should be equal to y. Means no element here is carried to decimals. This will be not related to anyone, so not possible. Therefore f is not 1 2. This cannot be bijective. But if the same question I ask you, f is a function from z to z, you verify, homework for you, z to z, such that fx equals to box of x. Integers you are taking. Is f a bijective function? You will try this one. Rest will continue tomorrow.